Hello. In this session, we will learn how to use the illustrative life tables and the the standard ultimate tables that comes from the Society of Actuaries. So if you write the actuarial professional exam, these tables will be provided in the exam, so you will be using them. It's also at the end of the textbook, you would see this table. But for consistency, as I mentioned earlier, we will use the same tables that are provided by Society of Actuaries. You can go to their website, soa.org, and download these tables, which I already provided them to you. So you would see, we already looked at this table. It has many pages, but I'll start it from page 60 to, life is 60 to 100. What you would see, we already last time looked at the cohort. The L is the cohort. We did add mortality. This one will come back to it later. Now we are here. So these are the ones we need to look at. And also these that we'll look at. So let's take a few examples and see how we can use them. But what I want you to make sure to understand that this is calculated at interest equal 5%. So we need to remember that interest is 5%. If it's different interest, then we will use different tables. But this is interest 5%. Let's take a few examples and see how we can use the tables to calculate some of the benefits. So remember last time we looked at discrete distribution. So using life table is discrete distribution. So benefit amount or benefit insurance is paid at the end of the year when death occurs. So let's see how we can calculate A70, and this is death occurs at in the year between 70 and 71, just before turning into 71. Then the payment will be made at the end of the year of 70. We knew how to calculate it, like manually if we are provided with information. But let's see how we can use the table. So simple, we go to 70, age 70, and we go here. So age 70, and we here, not to make mistake, is 42818. See, so age 70 and life insurance. So it's 42818. Easy. Now let's see if you want to calculate A70 for 2 years and term insurance. Term insurance is paid at the end of the 2 years. At the end of, like if death occurs within 2 years, there is a payment paid at the end of the year. So we look here, we don't have this one, right? We have, we can see here we have 20, but we don't have this one, but it's easy to calculate it. So we are now calculating it for 2 years. So there are several ways. One way I usually like to visualize it, especially if it's a little bit of years, 2-3 years, we can do that. So we are 70 or 4 years, we can, or little bit, we can do that. 71, 72. We are here. So we can A70 and the one on top of the 70, so it's term insurance for 2 years. If death occurs here, here, then the payment will be, you have V, the payment at the end of the year, so we discount it with interest, is V, and then death occurs Q70 plus. Now if death occurs here now, then this one payment will be made here, so it will be V to 2. Now death occurs here to survive to 71, so we need to survive to 71, so P70 and 1 here, multiply death occurs in this year, so Q70, 71. We did this one before, similar to this, but we are using the life table to calculate this one. What V, we know it because again life table interest is 5%. So let's go back to where we are. So let's see what we need. We need Q70, P70, Q71. Q70 and P70 is the same one. So we need a Q70 and Q71. You go back to here, same line 70, you copy this number and you copy this number 010413. So you have V multiplied, I wrote it here, 010,413 V2. Now, sorry, now plus V2, P is the complement of that one, 1 minus 0, 10413. And then Q71, again, you take it back from here. This one. 01167. Sorry, there is a 0. 11676. Right. So you do it for 2 terms. Now you can calculate this one if you use your calculator. And remember, I is 5%. So you calculate this one, it will be 0.20392. So a 70 term life insurance for somebody age 70 for 2 years, paid at the end of the year of death is this one, using life table. What if you want to calculate a 70? Instead of 2 years, you need to calculate it for 5 years. And here we need to use, you know, one way we can calculate it like this one, Q70 plus V2 P70 Q71 plus V3 P270 Q72 plus V4 3P70, then Q73 plus V5 4P70 Q74. You can calculate it this one, but especially if you are in exam, you need to save time. You know, there is alternative way, because here you will calculate 5 terms. Alternatively, you can calculate this one if you remember the relationship we looked at last time, right? So this is A70. Oh, sorry, this is 70. Is 75. Now here you can calculate A70, A75 provided to us by the table. So now if you can discount this back here, you know, that will be easy. So all you need to do for this one, sorry, is to calculate we need to calculate A70 for 5 years. Instead of doing this long calculation, you can calculate this one. Simply you take A70, you subtract from it A75. However, because A75 is not at this point, so we need to bring it back. How we bring it back? It's the actuarial discounting factor. So we discount it back for 5 years. Right? And 5E7 70, you can calculate it separately, you know, but if you go back to look at the table, you will find it, because this is very important term. So now let's go look at the table. So we need to look at A70. So we need this one. We need A75. Also we need A75. We need this one. And we need 5E70. We need this one. Right? So we have A70 A75 and 5E70. Right. So now take your time to log in and see what you get the calculation. For me, I just wrote it down here, so it's hard. I can't remember these too many numbers. But for you, you write it down and you calculate. Let's go back to our formula here. We already identified what we wanted from the life table. We found A70 to be A70 to be, which already we already did it here as well. This one, 42818. A70 is, let me use the same color. 42818 minus the discounting factor. The 5E70 is 0.73. 295. Now the A75 is 0.50868. It's a little bit high. Just wanted to double check, not that I'm not making a mistake here. Yeah, it's actually correct. It's this one. And by now you should have got the calculation. You should have calculated it, so you can compare your answer with my answer. So if you calculate this one, you should be able to get the A70 term life insurance of 5 should be 0.55342994. So $1 of benefit will cost about 5.5 cents for this life insurance, the term life insurance. Right? What if you want to calculate? Now the question is A75. This is simple because we know. Oh, sorry, not one. We calculated the one with one. Now without one. This is the endowment. Remember, with one is term, this is endowment, the endowment insurance. So it gives you $1 if death occurs within, let's draw it just to make sure it's also to remind us what we did last time. So you have 70 to 75. So if death occurs here, there is $1. If death occurs here, there is $1 here. If let's say if the individual survived to age 70, there is $1 here. If the individual death occurs here, there is $1. So we need to discount this back, and we need this insurance. So, and this is nothing, complicated like what we did last time. We can say the first term is A75, death occurs within 5 years, or the individual survived to A75, so the $1 at the 5. Different ways of writing it also. We can recognize that this can be written we can write it as E, the actuarial discounting factor of $1 of 5 years, right? So this is straightforward. You can calculate this one, you already calculated it, and you can calculate this one, right? So this one, we already calculated it just in the one before. This one is, we said it's 0.55343. We add to it now the 5E7. You go back to your life table. It's 73295. 73. Sorry, let me look at it. Make sure 73295, and this will give us 0.7883. Right? Does that make sense? You see, I want you to be careful here. Is the one is with one and one without one. Now let's also, since we are working on this, let's take another example here. Let's say we want to calculate now A70 for 10 years. And there is no one. There are many ways you can calculate like what we did. alternatively, you go directly to the life table. Actually, you should find this one. Let's go back to the life table here. So we are at S70 here. Again, we are S70, and we need to have it for 10, this one. And there are also for 20, right? So we need to take the 10. So now we take this one here. 6376. Right. So it's easy if in the table, but if you don't want to use the table directly, this alternatively, this can be calculated here. This one, if you want to calculate it this way, this one will be A70 minus 10E70. Right? This is the first term. Then you add to, sorry, I made a mistake here. I meant to say multiplied by 880. Then you add to it this 10E70. You can verify this same formula. You know, everything here is provided in the table. You can verify it just to see if you get the same answer. If you verify it, both of them, they should give you the same answer. I would suggest that verify it so you can see that both of them, they give you the same answer, right? So they should give you the very same answer if you verify it. Now let's take another concept here. Let's go back to the same table, life table. And now the table, what you know, that the table gives you the amount of death occurs, let's say 70, 71. So A70 here from the life table, the one we calculated, it tells you if death occurs here, the payment will be made at the end of the year. But what if we want to use the life table and we want the payment not to be made at the end of the year? Now we want the payment to be made at the time of death. So wanted how we can use the table. So we need how to use table for death occurs at, or for payment occurs at time of death. When payment occurs at time of death. And payments, okay, we need A70 now with bar. Remember the bar here? So we need to have an assumption here, right? So we need to have an assumption. There are different ways, but what we will use here now, using UDD. What we mean by UDD is uniform assumption. The assumption is uniform distribution of death. So we need to make sure that we're using the uniform distribution of death. It's very important. If it's not, there is no assumption, you cannot calculate it this way. So then AX, if we under UDD, uniform distribution of death, we can compute it in simple way. We have I divided by delta multiplied by AX. Let's look at this one. Now let's see what if you wanted to example using, it's important that we specify uniform distribution of death. Let's find A80. If you go to the table, you don't have a continuous one. You have, but what we know that 880, we can write it using a uniform distribution of this is I over delta multiplied by A80. Now I is 0.5% because the life table is 5%. For the life table is 5%, but in question in exam I can give you different life table or different, I can give you this different number. And delta, recall delta is ln 1.5, ln the interest, 1 plus the interest, and now multiply by A80. Now we need to have 80 and we need A, and recall this number now. Five nine two 59293. Now we need to multiply it by 293. 293. Now if you calculate this one, and usually I do it quickly, 0.5% divided by ln 1.05, this will give us 1 point. Just to record this one, I'll tell you why I wanted you to record it. Multiply by 59293 is equal, multiplied by 0.59293, 0.6076. Want you now to compare, this is A80 is, it must be bigger than A80, which is this one. And it makes sense because you give it at the moment of death. So the period that you discard should be shorter. You don't wait until the end of the year. So the value for money and will be shorter. The discounting factor will be shorter. So that's why it has a higher value, right? That's why it has higher value, right? So that's why it has a higher value. Just wanted you to know that you can also use this one under UDD. Can use this one also for this relationship. I over delta. Want you to be careful here. This is the term insurance. But if you deal with endowment insurance, caution, let me put caution here. There is no one here. This is not equal to it's not equal to. You need to be careful here, right? But how we can calculate this one then? How we calculated it, we go back to the, then AXN, but how to calculate AXN? If you want to calculate this one, then we write it first, AXN 1 plus AXN 1. And remember, there is no bar here because this one is discrete. This one is already discrete. This one is already discrete. Now, AX under UDD, now what you can do under UDD is X, this N, the without one here. This is the endowment insurance will be now under this one will be AX, sorry, will be I over delta AXN plus AXN. Right, and this can be written also, by the way, this can be written NEX, right? So this is correct. This is how you compute it. If you get a question like this is how you compute it. You split it and then you multiply by 1I over delta. Very important. You need to be careful about this one. Right? You don't do this one. This one is wrong. There is no 1 here, then you do this one, right? You need to be careful about this one. Now let's extend the discussion here. Now let's extend it. We looked at, payment occurred at time of death. We use a life table. Life table, remember, it's at the end of the year. We moved it to occurs at the time of death. A more realistic also insurance model that it's not either at the moment of death, people right at the moment of death they go claim the insurance benefit. It's not likely, but it's not likely that they will wait for the end of the year. It might be, either at the end of the month or, like at the realistic assumption, maybe every quarter or so. What if we want to calculate now, what if payment is made at the end of M, at the end of the M period of death. M period, not necessarily the long, not necessarily the end of the year, but maybe end of the month. So what we mean by M might be monthly, maybe weekly, quarterly, every 6 months. So a period other than 1 year. How we can deal with this one? Let's look at it. Let's look at period other than 1 year. So the assumption here, using UDD, same logic. Now what we'll have, A for the M referring to the, if it's M is monthly, it will be 12. If it's weekly, it will be 52. So it will be the paid at the end of the M period. It's equal the same logic. You have your I, like what we did delta, but now instead of delta, we'll do I M multiplied by A, sorry, here we have X, AX. Same logic here, we can also write same logic, AX N, and there is 1. Remember that important to be careful about the 1, is equal to I over I M AX N, there is 1. Remember here there is 1. Very careful about this one. There is 1. The 1 here, if this is the term, you cannot do it for the endowment. If there is no 1, you need to split it, like what I told you about the quotient before. But let's take one example here. Let's take one example on this one. Let's take example. Let's take, but before that, what is IM? What is IM? We already did it in the review for interest theory, but IM is just like the formula for it is you have M multiplied by 1 plus I raised to 1 over M, subtract 1 from it. So if you do that monthly, this I for 12, then you multiply M will be 12, 1 plus I, or 1 plus interest raised to 1 over 12 minus 1. But let's take example. And the important that the problem said that I gave you guys that you do them. Lots of you need to practice. I cannot go over so many problems in these video sessions. Otherwise, you will spend a lot of time listening to me. So we'll need to mix it. That examples I do it using recording it for you. Others I solve them for you. Others I keep the answer so you can practice yourself. So we'll have variety of ways of handling this. Now let's take example. You can use the life table, but let's say we want to use different I now. Given, so what we are given, AX is equal to 433. Doesn't have to be given to you. I might give you the life table, so you go in the life table and find it. Let's take different than 5%. Let's take 6%. Now you using UDD, find what we wanted is, let's say the insurance. It does. Maybe I don't write it for you. Maybe I'll say insurance paid monthly at the end of death of the month. Right, in the at the end of the month of when death occurs. Right, let's do that. Right, so AX. Firstly, we need I12. 1.6 raised to 12. 1 over 12 minus 1. Use your calculator. I usually do it all at once quickly. So I start 106, raise it to 1 over 12, then subtract from it 1, then multiply it by 12. Is 0.584. Right. Now 8x12 should be remember the formula, this I over IM. So 6%. Usually keep it in your calculator. Very important to keep it in your calculator so you don't lose any decimal. Multiplied by AX, which is given to us, AX in the question, 433. So let's do that. Just wanted you to know this. I'll come back to it before I forget. 0.272 multiplied by 0.433 gives us let me do it. Gives us this value, right? Why I wanted to multiply by this, just to show you that the relationship between this, now A12 should be bigger than A. And why? Because again, like similar to what we did before, again, it has to be bigger because it's like now you shorten the period of discounting, right? You give it right away at the moment of, not at the moment of death, but instead of waiting for 1 year or on average, 6 months in average, but instead of if uniform distribution of death. But in what you do here is not to wait, until the end of the year, but you give it right away. So it should have a bigger value, right? So what you would see here that A12 is bigger, and if you would do the moment of death will be also bigger, right? So we need to keep this. Why? Because this is the factor here, is this one is a factor, kind of, like you increase it to respond to that relationship, right? And this is very important. But let's take one example using also life table. use example another, because I wanted to explain another concept here. Example, using life table, and remember life table, I in the life table is 5%. Now we want to find a 1270, and this is, if you do it, it's the same logic. You will have 0.5 divided by let's just keep it this one, 12 multiplied by A70, and A70, if you go back to the life table, is 0.42818. Now this I12, I over I, or let's keep it here, you can compute it like what we did above, or there is also in the life table, it's also given to you. So let me show you, remember the life table, if you go to your life table, let me go back to all of them. This is, as I mentioned, I downloaded it from the Society of Actuaries website, helps us to see, just to see them. So if you scroll down the last page here, it has many tables. The last page here, which I scrolled it down, let me get it a little bit bigger. What you see here, they give you also the interest function, M different period. For this one here, this is the continuous case. So IM here is actually delta. If you do ln 1.05, you should get it, right? Let's double check it. ln 105. See? Because this is, this factor is very important, forget about the things that we haven't covered yet, but let's look at this one here, right? So I over I12 here, if you compute it, but it's going to give you the same answer here. I over, so we look at I12, you go to this one here. So the factor here that you need to look at is 10271. 1010271, right? This one. So you don't need to calculate it if I give you the standard life table, but I might give you different life tables, so you need to, like what I did before here, I give you 6%. So I give you 6%, so you cannot find it there. So I might give you, like 6%, so you need to know always how to do it. So this 1.277, you multiply it by this one, it will give you 0.4379, right? Which is bigger than A7. All right, we think we finished for this one using the life table. What we will do next session, we'll look at different. Here we looked at $1. We'll look. Of course, if the insurance is not $1, 1,000, then you multiply it by 1,000, the benefit. But it's also, it might be, like 1 year 1,000, second year 2,000, third year 3,000, varying benefit. We look at those, how we evaluate those benefits.